Hi everyone, and welcome back to my channel. So as you can see, once again I've leapt ahead in this build versus what I showed you in my last video. Since that video, I've installed the frets and have done some preliminary beveling of the fret ends. My next steps will be to level and crown the frets, and then to round the ends, sand and polish the frets, and so on. But for now, I need to take you back to where we left off in the last video and show you how I got there, meaning my process for mating the fretboard to the neck shaft, which includes installing the carbon fiber reinforcement rods, the truss rod, and a whole bunch of other preparatory steps before I can bust out the glue and clamp everything together. Now, at this stage, I remain pretty optimistic about this neck, while at the same time realizing that there's lots more to do before I can apply the final finish. In all honesty, given the amount of work that remains and the fact that most of it will be handwork, I would say that this neck is about halfway finished, maybe slightly more, but not much. The two other necks that I finished taught me that the devil is indeed in the details, and the amount of detail work required, even for a basic, merely adequate fret job, is considerable and tedious and time consuming. To be honest, it would be fantastic if there were more automated tools or methods for fret work, but absent a highly sophisticated robot or some other automated system that might exist now in a production facility for some major manufacturer, I'm not sure, most fret work still has to be done by hand. So with that in mind, let's take a step back so I can show you another process that's surprisingly manual, which is mating these two all-important pieces, the fretboard and the neck shaft. As I've said before, when you're building a bass or a guitar body, you've got lots and lots of leeway in terms of how the design decisions you've made or how you've executed the build to that point will affect the overall playability or even tone of the instrument. Like the pickup could be slightly askew, the volume knob might be too far away from where you'd prefer, or maybe the body could have been a little thinner or lighter or even thicker and heavier. None of those things will affect the playability of an instrument more than comparably small issues with the neck. Like I mentioned in the previous video, being a millimeter off in the placement of a fret slot is a deal breaker and introduces an insurmountable problem in terms of playability, specifically the instrument's intonation, whereas being a millimeter off in terms of pickup placement in one direction or the other would not make much difference. So again, with all that in mind, let's watch the process for mating the fretboard to the neck shaft, and then I'll be back on the flip side with some final thoughts. Okay, so the first step in this process is to install the carbon fiber reinforcement rods. You'll notice first that I've run a strip of masking tape across the back of the neck shaft. That's to prevent any residue on the clamps from seeping into the wood and staining it, which has happened to me a couple times even after cleaning the clamps. So to install the carbon fiber reinforcement rods, I'm going to mix up a little epoxy and then carefully drizzle it into the slots. Once I've done that, it's just a matter of inserting the rods into their slots, making sure that they are seated against the bottom of the slot to the extent possible. I try to go easy on the amount of epoxy I use so that I'm minimizing squeeze out, some of which will be unavoidable, but the less I have to deal with, the better. Once the rods are in place, I need to cover the top of the neck with some more masking tape, this time to prevent the clamps from adhering to the epoxy, but also to prevent the epoxy from contaminating the clamps in a way that comes back to haunt me when I use them in the future. Once the tape is applied, I'm ready to clamp the rods in place so that everything remains stable while the epoxy cures. Now, one thing to note about these carbon fiber rods, they are slightly different in dimension from the last set I purchased, and therefore slightly out of step with the dimensions I used in my 3D model. This means that the rods will end up sitting above the surface of the neck shaft. Not by much, we're talking about 0.5 millimeter or less, but even that small discrepancy is going to force me to do some more handwork than I would have preferred, which you'll see in the next scene. So here I'm basically using a card scraper in hopes of bringing down some of the high spots in the carbon fiber rods. I wish it would have worked better, but it didn't, so I decided to switch to sandpaper. Now, a couple things to discuss here. First of all, I'm using a sanding block that only extends slightly past the width of the carbon fiber rods. What I'm trying to avoid at all costs here is compromising the flatness of the neck shaft, especially at the edges, which needs to remain flat in order to get a good glue seam when I attach the fretboard. The second thing to discuss, obviously, seriously, and probably the reason why it's worth avoiding any need to sand or cut the carbon fiber rods, is that the resulting residue, whether it's dust or splinters, is a huge pain to deal with. For starters, it will stain anything it comes into contact with: wood, your fingers, your tools. After these scenes you're seeing now, I had black stains on my fingertips for far longer than any actual wood dye or stain I've ever used, period. This stuff is no joke, and I'm fairly sure it's also a serious respiratory hazard, and I probably should have been masked up with something more robust than a K95 mask. So now that the carbon fiber rods are installed and the surface of the neck shaft has been prepared, I'm ready to start prepping the fretboard for attachment. The method I've been using to register the fretboard to the neck shaft and keep it from moving around is pretty standard. The first step, which you're seeing here, is to drill a very small pilot hole through a fret slot at either end of the neck. These holes will be used to install the small registry pins that will keep the two pieces in alignment. But for now, I can simply point out that the tiny hole drilled through each fret slot will be concealed by the frets themselves, which are wider than the diameter of the hole. However, on the back side of the fretboard, the holes have to be wide enough to accommodate the registry pins, which is why I'm widening them here. The tape around the drill bit, by the way, is to prevent me from drilling the hole too deep and bursting through to the other side. With the holes prepped, I'm ready to install the registry pins, which are just little segments from the same rods of plastic that we use to create position markers. This part is kind of fiddly and requires a lot of minor adjustments, like trimming the pins to the correct length, widening the corresponding holes in the neck shaft, and so on. Now, I've seen a lot of other methods for this process on the internet, including not using any registration device at all and relying on one's own expertise or a specialized jig to prevent the fretboard from moving out of position once clamping pressure is applied. But at this stage, the version of the process I'm showing you here seems to work for me, and I'm definitely not skilled enough yet to get a decent result without it, which I've proven to myself in past attempts. And speaking of past attempts, here's kind of what I'm talking about. What you're seeing here is my initial attempt at a test clamping, using the same method I've used in the past, basically just applying as many clamps as will fit and hoping for the best. However, on inspection, I just wasn't confident that I was going to get the clean glue seam that I'm after, so I decided to build a specialized clamping jig. Now, I copied the design of this jig from the one that Chris at Highline Guitars uses on his channel. The concept behind it is simple. Take a long piece of flat, nicely planed wood and cut a channel down the center of it. This will distribute the clamping pressure along the most important areas of the fretboard, the edges. It doesn't matter nearly as much if the pressure isn't maximal or even in the center of the fretboard. Where it matters most is at the edges, where the glue seam is visible. So as I could see in this test clamp up, the fretboard was much more tightly clamped to the neck shaft along their shared edges. It's slightly difficult to see in the shot because of the small bit of overhang I've got going between the two pieces, but trust me, there's a big difference in terms of how the pressure is being distributed now. With all of the setup work now finished, it's finally time to glue the fretboard to the neck shaft. You can't see it, but I've placed the truss rod in its slot, and I've put a strip of masking tape over it to minimize any glue dripping onto the truss rod and gumming up the works. As usual, here I'm just squeezing on some glue and spreading it with my finger using a nitrile glove. I don't know why, but for me, spreading the glue with my finger gives me a better sense of the coverage as opposed to using a glue brush or one of those rollers. Now that the glue's been applied, I can remove the strip of masking tape and start maneuvering the fretboard into position using the two register pins I installed in an earlier segment. As with the test install, this process can be a bit fiddly, which is compounded by the slipperiness of the glue. However, once I've finagled it into position, I can be fairly confident that the fretboard will not shift in relation to the neck shaft once I start applying the jig and the clamps. Of course, it never hurts to do one final check with your hands and eyes just to make sure that the assembly is properly aligned and secure. Any mistake made now could potentially carry through to the final result, no matter how well the clamps have been applied. My first step is to position the jig and make sure it's correctly aligned with the neck. In particular, I need to make sure that the jig doesn't extend over the little recessed area at the base of the neck heel, which is going to require separate clamps. After that, I'm going to apply clamps at both ends and then in the middle, and then from there start filling in the gaps with the remaining clamps. One thing I need to be careful of here is to apply the clamps toward each edge of the jig rather than toward the middle. Again, the goal here is to apply the most clamping pressure near the edges of the fretboard, which will result in a tighter, cleaner glue seam. Last but not least, I need to apply a couple of clamps to the base of the neck keel, as I mentioned earlier. After that, all that remains is to let it dry and then remove the clamps and see how it turned out. Okay, so the clamps are off and the seams look pretty good so far, but I won't know for sure until I've removed all of the squeeze out. My method for doing this is slightly controversial, and I put that word in air quotes, but what I do is I use a heat gun to soften up the glue so it's easier to scrape off. Now, I've had a couple of people much more experienced than I say that such a method runs the risk of compromising the seam and weakening the glue bond. But from what I can tell, it would take lots and lots of heat applied for quite some time before the seam would weaken in any appreciable way. In other words, it would have to penetrate pretty deeply into the wood to really affect the integrity of the seam. And from what I've seen so far, it simply doesn't. Okay, so as I often say, there you have it. My process for gluing a fretboard to a neck shaft. I don't have much of a post-mortem to offer here beyond thanking you for watching my video. As I indicated in my intro, the next segment will involve installing the frets, which could occupy the entire episode for all I know. I was working with a new jig that I designed based on a jig that I saw in one of Anka Custom's videos. If you don't know Anka Custom guitars and basses, I would highly recommend that you check out their channel. They build amazing instruments and use a lot of advanced techniques. Well worth watching. In any event, my new jig proved to be a bit challenging for me, though I'm super pleased with the results. I'll discuss that and more in the next installment, so until then, take care, and I look forward to seeing you next time.